Okay, everyone. Like I say, you won't have to take notes, but I will request your attention for the next few minutes, and hopefully we'll have something useful for you that you can use. In today's lesson, we will be discussing a process by which you can design information systems, such as software systems, in a way which is structured and repeatable, but it can also be adapted to different systems and different projects. Now, this might be obvious to some of you, but I want to spend a moment talking about why having a design process is important. So eventually, as a builder of software, whichever branch you wind up in, software engineering, developer, user interface, you will have to design and build parts of or entire applications. Now, this could be because a client is paying you for your service. It could be that a project manager has given you a task, or it could be that you are an independent developer who wants to build and sell a product. So, before we proceed, I'd like you to ask yourself a question. Are you confident in your ability to design applications? Now, in case there is any confusion, when I say application and software system, I am speaking of the same thing here. It's a collection of source code which is executed on a computer of some kind. So, in keeping with the theme of this lesson, we will start with a very general idea of this process. If you would like to research it further, the technical name of this process is problem domain analysis. Now, the thing about that big scary word there is that it does not make much sense even to native speakers of English. So that's why I chose this term top-down analysis. But understand, if you want to research it further, problem domain analysis, and I don't even really want you to use the name top-down analysis. I chose that as a teaching tool, and we'll see why in a moment. So this name top-down is really just a way of suggesting that you design and build the most general, high-level details, and over time, you design and build the low-level, specific details. So we'll see some examples later on of what I mean in more specific terms. This will help you to organize your projects in the beginning. It will help you to see problems in the foundation of the system, which are only obvious from a high perspective. And it'll allow you to make big changes and optimizations in the foundation before, but not after, you are close to completing the project. To speak from personal experience here, when I first started writing code, I didn't know how to build a solid foundation for my applications. And when you start building on top of a bad foundation, what you'll find is eventually you'll reach a point where you have to rebuild it completely. So just a little bit of personal experience talking there. Now, my intention is to keep this talk very generalized, but a general detail might be what the application does. We'll see some examples. And then a specific detail would be how the application does it. So, does the application store data? And then what tool, what API, what library, what tech stack does it use to store that data? That's a little more specific. I could have called it bottom-up analysis, which is to say that we first design and build the foundation of the structure, and then we worry about building the next layer, and then the next layer, and the next layer. But this is really just another way to express the same idea. Also, please forgive me for using a stereotypical analogy of a pyramid, but the truth is that carpentry and construction have many common principles to software design and engineering. One thing in particular that I notice with my past experience in construction and building programs, like I said before, is that a small mistake in the foundation can cause huge problems as you continue building on that foundation. Now, you're all software developers, engineers, and so forth, as far as I'm aware. So we will return to that specifically and talk about how we can apply this idea. So hopefully we understand the basic idea, or I've given you like a general model of what I'll be talking about. And I would like to remind you that we can see these principles pop up in many different fields. It can apply to business models, or for example, the lesson plan that I wrote and am teaching today, I use this same principle. So, simply put, we start with what is the process? We start with a plain language description, or descriptions, plural, of the application or a specific feature of the application. This is especially important if you are working with clients and coworkers who may not have much technical expertise, but still want to be involved, for good or bad, in the design process. Now, there are, in the software development world, two common ways that I see to apply this process, this first step, and they are fundamentally the same, but we'll look at a couple different examples. The first approach is called a problem statement. So it is a simple, plain language, you can write in Arabic if that works for you, plain language description of a system or application. So, for example, the application will record daily temperature readings from a public web service and display a graph based on readings for each month. Now, we will revisit this point shortly, but when you write these problem statements, pay very close attention to the nouns and the verbs. By nouns, we are talking about the objects or things. By verbs, we're talking about actions or processes or functions, things of that nature. We'll go into that a little bit more in a moment. The other approach we have is something you've probably heard of, some of you at least, and it is very popular in the tech industry. It's called a user story. So a user story is simply a problem statement, but it is written from the perspective of a user of the application. And this is the case even if you are the developer of the application. You will still write it from the user's perspective. So, for example, I have written a couple of user stories. As a user, I would like to view my contacts. As a user, I would like to edit my contacts. As a user, I would like to send messages to other users. Again, pay close attention to the nouns and verbs. Notice how every user story has one primary verb. Sometimes you will have multiple nouns, multiple things, objects, and that's okay, but as a general principle, I prefer to see that you have only one primary noun, unless you have a good reason not to follow that principle. So, one last point before we proceed. When you are designing and building a new application, start with fundamental basic features first. I don't have a lot of time to go into detail here because this is its own big lesson, but if you want to learn more, look into Agile versus Waterfall software development methodology. Like I said before, if I'm going really quickly through this, I can provide you the slides, so don't worry about frantically writing anything down. Anyways, moving on. So let's assume you've written out some problem statements or some user stories, and those things model the basic features, the foundation, like I've been talking about, of the application or the website that you're trying to build. So the next step can change depending on what you are building and depending on your preferences. If you are building a static website, or you are working on something that's really heavily involved with the user interface, it might make sense to go straight from our previous step into designing the user interface. Since I spend most of my time in software architecture and engineering, there is one more step I like to follow before I start thinking about the user interface. Remember how I said to pay close attention to nouns and verbs? Well, the reason why is that you can use these immediately to start writing some meaningful code. So, for example, from the nouns, we can figure out our variables, constants, fields, classes, data models, enums, dictionaries, etc., etc. These are all just different ways of modeling information in a computer system. We can use those tools to basically model what we need to model, whatever our application needs to do. Obviously, this will change depending on your language and platform, but we can go straight from looking at these nouns and use that to inform our data structures, essentially. As for the verbs, these can help you to determine the functions, methods, interfaces, use cases, protocols, APIs, and much more. Now, how you model these things, again, it's going to depend on your programming language. But by the time you learn your 5th programming language, these things will all look very similar, even if the names change. I mentioned earlier that after you write your user stories or problem statements, the next few steps can change depending on project requirements. This phrase, project requirements, is one of the most important phrases to know and understand in our industry. Project requirements are the various things we must be aware of in order to successfully design, create, test, and publish a product, a website, an application. These things change from project to project, but I have included a list of common things to think about from there. Your personal preferences as a developer. Maybe you prefer to go into the user interface and then that informs the structure of the data. Maybe it's the other way around. Are you working on a team? Do you have clients who have requirements you have to satisfy? Project managers? These are all things we need to take into account depending on the situation. How big and complex is the application or the website you're building? Resources, how much time do you have, etc., etc. Your technical skills as a developer. So the point I'm trying to get at here is I'm giving you a very general idea of the approach, but be ready to experiment and make it work for you. So what we'll do is we're just going to review this general process one more time. So we start with some kind of idea. For example, I want to build a social media application, or I want to build a website of some kind. Next, we design the basic foundation and the features of the application, and we don't try to design the whole thing up front. We just want a simple working version of the idea that you're trying to build, the basic features. And we design this by writing user stories and problem statements. And again, we do that step in plain language. This is not a waste of time. We are designing the application in a way which is simpler for everybody, including us developers, to think about instead of getting into the code and the implementation details and then trying to design the project at the same time as trying to solve those implementation problems. These are separate, so we want to do one thing at a time. From your user stories and problem statements, by looking at the nouns and the verbs, you can begin to derive basic source code. Now, again, I've written 3 or 4, that's not meant to say 3/4, because if you prefer and it makes more sense to you, you can then go from there straight into designing the user interface. Now, some of you might be wondering, well, which approach should I use? My advice, and this has been something I've applied throughout my career, is don't make strong decisions until you test different approaches out. Try it out for one project, doing the user interface first, and then for the next project, try starting with the structure of the data, the functions, those sorts of things, and then go into the user interface. In either case, again, we're not trying to design the whole thing up front. We're trying to have these different stages build on top of each other and help each other. From here on, your job is simply to repeat this process for every new feature or new application. Design, build, test. Design, build, test, etc., etc. So, hopefully I gave you a good starting point and a general understanding of how to design software systems, and by extensions, systems of any kind. That is my lesson for today.